touch on the 4080 12 gig versus 4080 16 gig, because the downside about moving as fast as we did about making that video about a specific keynote and only reporting on what he showed in the keynote is the fact that sometimes some things go up later that then really kind of open your eyes to some things. So we know there's 4 cards right now already kind of announced: the 4090, the 4080 16 gig, and the 4080 12 gig. One of the things that made me kind of not really think about the 4080 12 gig and 16 gig being that big of a deal initially is the fact that it's kind of like how we have a 3080 12 gig and a 3080 10 gig right now. Essentially, core-wise, they're the same GPU. It's just one had 12 gigs of VRAM and one had 10 gigs of VRAM. So didn't seem all that odd to see a 4080 16 gig and 12 gig until you really start to dig deeper. If we talk about CUDA core counts alone, the RTX 4090 has 16,384 CUDA cores. What's interesting is the specs, they don't show me how many RT cores or how many tensor cores or any of that yet. Because initially on the CUDA core count alone already, this looks bad, and it might be potentially worse once we see the full actual die breakdown. The RTX 4080 16 gigabyte has 9,728 CUDA cores. Yeah, it's a lot less. So in my mind, that already means there's room there for 4080 Ti already. That's the 16 gigabyte variant. The RTX 4080 12 gig has 7,680 CUDA cores. Already calling it a 4080 is very disingenuous, because if it had been just a 12 gig versus 16 gig variant with the same core, then that means that you could call it a 4080. This is for a few reasons. One, the shave down progression here, the 4080 really is just a renamed 4070. And the thing is, I feel like NVIDIA just felt like it could change the name to whatever it wanted and get away with it. But this looks very bad in terms of buyer misleading. Because initially, if you're shopping for a 4080, and they don't put these CUDA core specs and stuff on the boxes, by the way. Let's say you're at Micro Center, like we were just at, looking at graphics cards, and you're holding both of these boxes in your hand. You'd be like, well, 4080, 4080, 12 gig, 16 gig. I don't think I need 16 gigs. So you put that back, you grab a 12 gig, you go, hey, it's cheaper. $1,200 versus $900, $300 cheaper. And you go, oh, I'm gonna grab that one because I don't need 4 gigs for $300. That's a bad deal. And you walk away not realizing you also got a completely different core. So for instance, when it comes to die naming with NVIDIA, the lower the number, the bigger the die. So it's kind of backwards. Like it's kind of like wire gauging. The bigger the wire, the thicker the wire, the lower the number on the gauge, right? So like a 4 gauge would be much thicker than like a 10 gauge. So the 16,384 CUDA core RTX 4090 is the AD102 core. The RTX 4080 with the 9,728 CUDA cores is the AD103. And then the RTX 4080 12 gig is the AD104. Here's the other funny thing. If you actually look at the core naming conventions of previous graphics cards, the 104 is typically where the 70 is. We saw this with the 600 series. There's so much history to talk about here. We saw this with the 600 series where the RTX, RTX, third generation RTX. It's weird to see a G in front of anything right now, but the GTX 680, for all intents and purposes of the way it was spec'd, the size of the die, the cut of the die, the name of the die was really more like a 660. But it was one of those where they had made such a jump with Kepler over Fermi that it looked like they just lowered the entire stack down on what they were making, kept the price up, and then because the generational improvement between Fermi and Kepler was so big, you could tell just by looking at the specs that it was just named higher, even though it was a lower end product. At the end of the day, it performed really well, so people still bought it because of the generational jump. It was where expected. Then the 10 series came along, and the GTX 1066 gigabyte card was a thing, but then they launched a 1063 gigabyte, where NVIDIA was called out for all of this again, where the 1063 gig was also a shaved down core from a 1060, 6 gig. So again, looking at the boxes, and I think I made this exact video about the 10 series, where if you're a buyer and you're looking at the box, once again, they don't put specs on the box other than core count, or not even core count, just memory, how much VRAM is on the card, and what family it belongs to. They don't put like on the side of the box a full spec rundown. By the way, I feel like somehow the FTC or the Federal Trade Commission should start requiring this on the side of the box. I really do. I really do think the full spec rundown needs to be on the box because they have to be fully transparent, because when you name it the same as something and it's not the same as that thing, then it's disingenuous, it's misleading, and it's intentionally duping the buyer, as far as I'm concerned. But the 1060 6 gig versus the 3 gig was also a shaved down card with the same name and lesser performance. Lesser money, lesser performance makes sense, but it's the naming of it all that really has me upset. Because here's the thing. I feel like they could have called the 4090, fine. The RTX 4080 could have maybe been called a 4080 Ti. Again though, there's a big enough gap in the CUDA core spec that they're probably already planning on a 4080 Ti, so they can't really do that. And then the 4080 could have still been called, or 12 gig, could have still been called the 4080 12 gig, and then the 4080 Ti 16 gig. But the problem is that gap between the 4080 16 gig and the 4090 also being $1,200 versus $1,600 is $400 worth of room to put another card in there. So they couldn't do that. So instead of calling the 4080 12 gig a 4070 at $900, because we would have never seen a 70 series card launch at $900, the misleading duping attempt once again of NVIDIA saying our customers are stupid, they'll buy whatever we put out, of calling it a 4070, people would have called out the $900. So instead they changed the name thinking nobody would really, I think, call this out. There's also another possibility here. NVIDIA knows and they just don't give a frick. They don't care what you, the consumer, have to think about their naming scheme because the pandemic has shown them that people will spend exorbitant amounts of money at a marked up rate to have a graphics card and they're still selling, so who cares? At the end of the day, NVIDIA doesn't care if it's deep pockets buying their cards or average gamers buying their cards, as long as someone's buying the cards. The funny thing is, I've been reading a lot of comments on the 40 series launch videos. Mine, Steve's, Paul's. I don't know, did Linus do it? I didn't watch it, so whatever, it doesn't matter. I've been reading a lot of the comments on Twitter, on NVIDIA's own pages and stuff, their forums. So many people are saying, not only am I skipping 40 series, they're not even buying 30 series right now because they're really waiting for November when RDNA 3 launches. I feel like NVIDIA's in this really weird spot where kind of how Intel was caught off guard with the whole like, we think people will just adopt the, let's just wait and see kind of a thing when it comes to Ryzen. I feel like NVIDIA doesn't really feel that AMD was ever a threat, but I think enough consumers now have kind of had just enough of the NVIDIA bullcrap when it comes to the marketing side and the management side and the general way they treat their customer side, that people are actually waiting now. One thing to mention here is the RTX 4080 12 gig does have a 2610 megahertz boost clock. Like the boost clocks on these, I can't perform. Here's the thing that sucks about this whole discussion. I love the product NVIDIA makes. I just wish it wasn't backed by so much just negativity. So much negativity around it. The product is awesome. The people engineering the products are awesome. The customer, the engineers, the employees working on this are awesome. It's just so much from the top makes it all look bad. 2610 megahertz boost clock. It took LN2 and custom BIOS and mods to make a 30 series come anywhere near that clock speed. 2.51 gigahertz boost clock on the 4080 16 gigabyte. It makes sense that the lesser dense core would have a higher clock speed because less cores. There's a whole reason why behind it, but lower end die cuts tend to boost higher for voltage reasons and all sorts of things. But 2.52 gigahertz boost clock on the 4090. And Jensen saying they've internally played around and overclocked it to over 3,000 megahertz. I don't know if that's a golden sample. We're talking almost over 400 megahertz overclock. That's significant, but not what would be significant too is also the wattage. If it's 450 watt at these boost clocks for the 4090, imagine what it would be at 3,000. But he did say, regarding the price increases, now we're not talking about, I don't know, it's just weird because I mean, obviously with it being this much faster, they're gonna wanna capitalize on it. They are a for-profit company and they're gonna up the price according to, okay, if we're giving you 50% more performance, but we increase the price 20%, it's 50% more performance for 20% more money. That looks good on paper, but the problem is you do that long enough, you eventually price out your entire industry because you can't keep adding 20% cost every generation. So that's why when 30 series came out versus Turing, it looked so good because the price went from $1,200 for a 2080 Ti down to $600 for a 3080, which was so much faster. But now we've gone back to that other part of the cycle where now you have a starting price of the 4080 12 gig at $900, which is $300 more than a 3080, or $400 to $500 more than a 3070. But Jensen did say that the price of the 12-inch wafer has gone up at TSMC. That's true, because even if we look back here, December 15th, 2020, Tom's Hardware did put out an article here saying TSMC is reportedly terminating the discounts, like the volume discounts, and increasing prices. And I'd read that prices were increasing as much as 20%. So now let's say that you're NVIDIA, 20 series was a TSMC product, you're getting a volume discount because you're ordering millions of them, and then suddenly that volume discount's gone, so that's a price increase. And then you're brought back up to market value plus a price increase on top of that. So it could be costing you 30% more. Let's not forget, 30 series was manufactured on Samsung. So now you're a customer that left, you went over the fence to where the grass looked greener, and now you're back. You're not necessarily TSMC's best interest to give you a deal at this point, because they know you need them. And so they're gonna gouge you. And who they're gouging is not NVIDIA, because NVIDIA is just pricing and gouging you now. So the price, the cost increase is passed along to you. And that's why the 40 series pricing was reportedly, and we talked about this back in like June or July, the 40 series pricing was expected to be pretty high. I see a lot of people surprised by this pricing, and that shocks me because of the fact that there was just so much data pointing to the fact that it was going to be expensive. I'm curious, are you gonna buy? I saw a couple comments that were like, F it, I don't care, I'm buying a 4090, I'm going all out. And if you're a performance snob, that's the route to go. Because you're not gonna care about who made the product, you're not gonna care about the philosophy of the business, you're not gonna care about the price. If you have deep pockets, you just want the best. And it's gonna come at an exponentially more expensive cost to have more performance. And you wouldn't care about this video anyway, you probably already decided you're buying it. I'm just curious as to how you guys feel about the 4080 16 gig versus 4080 12 gig naming scheme. Because here's the thing now, there's not a lot of space between a 4080 12 gig and a 4080 16 gig, so they can't slot a card in there. You're gonna have two 4080 Ti's, or are we gonna have a 4080 12 gig, a 4080 16 gig, and a 4080 Ti? Are you gonna have three 4080s this time around? That's gonna be weird. 4070 now, you know is gonna cost at least $600 to $700, probably $700 if it comes to that point. And you know there's gonna be a 4080 Ti. You just know it, because there's too big of a gap. 16,384 CUDA cores versus 9,728. Funny thing is the 4080 16 gig actually has less CUDA cores than the 30 series, but generational improvement on the new 4N process, or the new 4N from TSMC, is gonna be so much faster, obviously. But again, if they would just try to look consumer-centric for once, they might not have so much negative backlash in everything that they do. Great products made by a company that just seems so far removed from the consumer now, it's not even funny. And as a fan of NVIDIA products, I'm so conflicted. Anyway, sound off down below how you guys feel about this. If you hadn't heard about this, I'm sure the videos about this have been existing since yesterday. I just went and put it out because I feel like it's my duty, obviously, to let the audience know, like, hey, you either care about what it's called or you don't. Because reality is, I did see comments on some of these posts about the 4080 thing, saying, I don't give a crap what it's called as long as the price to performance is there and makes sense. We haven't benchmarked these yet. The 4080 12 gig being called a 4080 or 4070 at $900, if it performs really, really well, might not matter at the end of the day. It's just about the optics of what it looks like the company's trying to do to the consumer. All right, guys, thanks for watching. We'll see you in the next one. Yeah, you read the title right. EVGA is no longer
Humans are the most successful and the most destructive predators on this planet. We kill and eat many of the world's animals every day, and we're able to do this despite being physically unimpressive. Humans are very soft and squidgy, and we don't possess sharp claws, sharp teeth, or strong jaws. We have gotten to where we are because of our intelligence, and our ability to use tools, make weapons, and build shelters. If we find ourselves in the wild without these things that have made us so successful, humans can be very vulnerable. In some cases, large predators will target humans as a food source, and this is a reminder that we are not untouchable. Although some apex predators will target humans, there is also a surprising number that won't. We have built very strange relationships with many of the world's creatures, some of these being apex predators. In this video I will be focusing on some of these apex predators and the relationships that we have with them, as I'll be going through 3 apex predators that don't hunt humans. To encounter our first species, you can travel to any ocean around the world, as I will be talking about the orcas. Now, orcas are possibly the most impressive predators on this planet, and they are simply unrivaled in their natural habitat. Orcas are also known as killer whales, which can be quite a confusing name. These creatures actually belong to the oceanic dolphin family, but many members of this family, including the orca, are known as toothed whales. In fact, their common name was given to them by sailors, who observed them hunting other whales. Orcas are in fact the second most widespread animal in the world, only second to us humans. They can be found from the Arctic to the Antarctic, and have been able to adapt to all climates. They're so adaptable in fact that they don't just limit themselves to the world's oceans, as they're even known to swim upriver to hunt fish. One specimen swam 100 miles up the Columbia River in Oregon, and this sort of behavior has been seen in other parts of the world. One of the things that has helped orcas become so successful is the fact that they are very intelligent and have very large brains. They have the second largest brains of any marine mammal, second only to sperm whales. This large brain helps them to have impressive social, language, and echolocation abilities, and this in turn allows them to have very tight bonds with each other. It's thought that only elephants and higher primates have more complex social structures, and this is why many experts believe that it is inhumane to keep them in captivity. In the wild, these groups are mainly made out of a matriarch, her sons and daughters, and the descendants of her daughters. Males will mate with females from other pods, but then will eventually return to live with their mothers. Because this is such a tight family bond, it allows them to effectively work together, and there are very few predators that are more impressive. Orcas will feed on almost all aquatic animals, and different groups specialise on different animals. As orcas can be found all over the world, there are many differences between the different populations. These populations are split into different ecotypes, which are different populations with different diets, behaviours, and vocalizations. Some of these ecotypes specialise in hunting fish, and others specialise in hunting large mammals. Famously, one of these ecotypes around South Africa choose to hunt great white sharks. These are very impressive apex predators themselves, but even these large fish fear the orcas. They are known to disappear when orcas are around, and when orcas kill great white sharks, they tend to only feed on their nutrient-rich livers. In the Arctic regions, they famously target large mammals, and have very inventive ways of targeting them. Some will swim very close in synchronization, and create a wave to knock their prey off of ice sheets. Because orcas simply fear no creature, and also sometimes come into contact with humans, it is rather strange to think that no orca has hunted a human in the wild. Although this is a very interesting fact, there has been some close calls. Of course, there has been attacks and deaths in captivity, but this is mainly due down to the poor treatment of the orcas, and it is unknown if they are purposely trying to kill their trainers. This may not have been the case for one killer whale though, because out of the 4 human fatalities caused by killer whales, one orca named Tilikum was responsible for 3 of these fatalities. In the wild, there has also been some close calls, because as far back as the 1910s, orcas have been recorded trying to push humans into the water, and in some rare cases they tried to sink boats. In September 1972, a Californian surfer was reportedly bitten by a killer whale. This is one of the only well-documented instances of a wild orca biting a human, and although it's disputed whether he was bitten by a shark or an orca, his wound did require 100 stitches. But this still leaves us with an interesting question of why orcas don't attack humans. They are more than capable of doing so, and it would require very little effort. Well, one possible reason why they might not do this is their intelligence. Orcas seem very fascinated with humans, and often spend a long time trying to work us out. These mammals are also capable of very complex emotions, and do feel grief to some extent. Famously, one orca carried her dead calf around for 17 days, as she was simply mourning the loss of her offspring. This makes orcas seem like very emotional creatures, and it may seem that they aren't just ruthless killing machines. Although we may seem very soft and squidgy, we are less nutritious than most of their prey. They often target animals with high fat and protein content, and we are relatively low in and nutrients. Because we live on land, we are also very bony, and it may not be worth it for these orcas to kill us. Despite the potential danger, sometimes humans do swim with orcas, and you could assume that this would be relatively safe. If you were to swim with the fish-eating orcas, you would be very safe, but this might not be the case if you were to swim with the mammal-eating orcas. So really, there isn't one reason why orcas don't hunt humans, but there's really quite a few. Despite this, there could still be an incident in the future where one orca decides to take a bite. But for now, I'm very happy that these creatures don't hunt humans, as we would simply stand no chance. But for our next group of animals, we will be heading onto the land, as we have the wolves. Famously, wolves are a very widespread species, and are also very effective predators. Instead of catching their prey with speed, they wear them down over a long time, and it is essentially their stamina that helps them catch their prey. This is a very similar strategy to the one that we once had, and throughout much of our existence, many human populations have lived alongside wolves. We first domesticated them around 130,000 years ago, and they are the reason that we have man's best friend today. But for many people, this animal's inclusion on this list is very confusing, because sometimes wolves do attack and kill humans. From 2002 to 2020, there were 489 confirmed wolf attacks, but surprisingly 380 of these were rabid attacks, and 42 were provoked defensive attacks. This leaves only 67 attacks that were thought to be predatory, which is still a relatively small number. Many of us live in areas with populations of wolves, and in most cases they are very shy and tend to leave humans alone. This is despite the fact that they could easily take down a human, and history has a few cases proving this. It's thought that because we have lived alongside wolves for so long, they have learned that we are potentially dangerous and shouldn't be messed with. Our stance is also another factor behind this, because as we are bipedal, we do not appear as a prey animal. Another reason is that we're simply not worth the effort. There are plenty of other prey animals that the wolf could hunt, and they wouldn't fight back as hard as we would. These other animals are also much larger than we are, and contain a lot more meat for the wolf to feed on. In most cases, when wolves attack humans, it's out of desperation, and although they can be very dangerous, they're yet another predator that tends to leave us alone. But for our next creature, we will be heading back into the oceans, as we have the leopard seal. Now, following elephant seals and walruses, leopard seals are the third largest pinnipeds. They can reach lengths of up to 3.5 meters and can weigh in at almost 600 kilograms. This large stature means that they can hunt very large prey, and they're known to target Ross seals, crab-eater seals, and Weddell seals. But leopard seals have also proven to be very adaptable predators, and they're also known to hunt surprisingly small prey. You may notice that leopard seals have very strange teeth, with some of them even looking like combs. They use these teeth almost in the same way that baleen whales filter their food, as they use them as a sieve to strain krill and fish from seawater. Possibly the leopard seal's most preferred prey is penguins. They have proven to be very effective at hunting this prey, and in some cases they even turn it into a game. They are known to play with their prey, sometimes letting it go and then catching it again. This may seem very cruel, but this also shows us that the leopard seal is also a very intelligent creature. Although it is not widely known, a leopard seal has killed at least one person. Back in 2003, a British biologist known as Kirsty Brown was killed by a leopard seal while snorkeling in Antarctica. The seal approached her and then dragged her down into the depths, and although she was brought back to the surface, the other biologists were unable to resuscitate her. This was the first and only recorded human fatality from a leopard seal, and just goes to show us that they can be deadly. As well as this very negative leopard seal encounter, there has also been very positive ones. Many wildlife cameramen have been in the water with these seals, and these predators tend to treat humans in a very strange way. Just like with the orcas, they seem to be fascinated with humans, and almost try to build a relationship with us. They have been recorded giving divers dead penguins, almost in a way to feed them, or teach them how to hunt. This is very strange behaviour, but yet again proves their intelligence. It seems that we are as fascinated in them as they are in us, and even though they could easily take down a human, and do take down prey as large as us, they're yet another apex predator that doesn't hunt humans. Of course, there are many other creatures that could have made it on this list, and if you know of any, let me know down in the comments below. But thank you for watching, I hope you enjoyed. If you liked it, please leave a like and subscribe if you want to see more videos like these. But until next time, goodbye.
In the animal kingdom, intelligence has evolved in many different ways in many different creatures. We often think of our fellow primates at the top of the intelligence list, with their ability to use tools like sticks and rocks to access food, and with their ability to recognize themselves in the mirror. Orcas, too, are among the most intelligent, with their unique language skills and orchestrated hunting techniques. And anyone with a dog is constantly surprised at complex feats of social intelligence and emotional sensitivity. Intelligence seems to thrive in animals like this, mammals, often carnivorous ones, that live in tight social groups. But if we survey the world of animals, one of the smartest is one that is perhaps unexpected. An animal that isn't a mammal at all, but a bird, crows, or more generally, corvids. Corvids are mischievous, playful, and extremely intelligent. They use tools to forage and to solve complex problems. They even drop nuts on a road for cars to crack, and then pick them up with the safety of pedestrian lights. They can also recognize faces, and can hold a grudge against someone who was rude to them for several years. They can mimic sounds that they hear, and scientists have found that their problem-solving skills rival that of a 7-year-old human. How is it that crows are so profoundly intelligent? And how is it that we even measure their intelligence in the first place? Is bird intelligence wired in the same way as mammal intelligence? Or is it something different altogether? The corvid family is also known as the crow family, and includes crows, jays, ravens, rooks, and magpies. The level of intelligence varies between the species, but scientists have found that the New Caledonian crow is the most intelligent. They're to corvids what we are to the rest of the primates. In 2014, the crows were presented with various tubes filled with water, with a treat floating on top, which they couldn't quite reach. In one trial, when presented with a treat inside a tube of water and a treat sitting on top of sand, the crows knew to drop rocks into the water-filled tube to raise the water level to reach the treat, and ignored the tube with sand. In the next trial, when presented with a single tube of water and objects with various densities, the crows knew to select the sinking objects rather than the floating ones to reach the treat. When presented with 2 tubes of differing water levels, the crows knew to drop objects in the tube with the higher water level to reach the treat faster. These trials demonstrated the crows' abilities in both problem-solving and tool use, and the authors believe that their skill level at deciphering and completing these tasks is similar to 5 to 7-year-old children. However, in 2 more challenging tasks, the crows didn't perform as well. One required understanding the difference in a wide tube versus a narrow tube, and another was a counterintuitive task, where the tube with the reward was connected to another tube via a hidden U-bend. The crows didn't fully grasp these setups, but in comparison, during tests with human children, only kids around 8 years old were able to consistently solve such tests. And in addition to using tools, New Caledonian crows can build tools. And not just simple ones, but ones with multiple parts. When given objects that were too short to retrieve food from a puzzle box, the crows combined elements by inserting one stick into the hollowed opening of another to make a tool long enough to reach the food. One crow even made 3- and 4-part tools. Compound tool construction like this has only been observed outside humans in a few captive great apes. It's usually only associated with human intelligence. And in addition to this, we now think crows might be better than we ever could have imagined at making plans for the future. The ability to take actions now that will give a benefit later is not something that most animals are good at. Delayed gratification and planning are high-order skills. Human children can't do this, and neither can many of the adults that I know. It requires our memory of the past and foresight for future events. Can crows, of all animals, really possess this ability? In a study published in 2020, New Caledonian crows were first shown one of 3 puzzle boxes that they already knew how to open, each requiring a specific tool. They were then removed from the test area for 5 minutes before being presented with 5 different objects. 1 tool for each of the boxes and 2 distraction objects. After selecting an object and waiting 10 minutes, they were allowed back into the test area. The researchers discovered that not only did the birds choose the correct tool that would open the corresponding puzzle box, but they would remember to bring the tool with them into the test area. In another study, researchers presented the birds with a locked box with a treat in a similar manner. But this time, the birds were then presented with an assortment of items, including the correct tool, a few distractor tools, and an immediate food reward, but one that was less appealing than the one in the locked box. And most of the time, the birds took the risk and delayed their gratification, kept the correct tool, and later opened the box with the better treat. This might seem easy to us, but it isn't. Only once human children reach 5 years old does this ability arise, and even then, it doesn't in all of them. For some, it takes a few more years. These mental skills certainly set crows apart from other animals, with their actions and abilities more in line with the smartest of the primates. How does this bird give the most intelligent primates a run for their money? Why does a bird need to be this smart? Even though crows may have a similar intelligence to many primates, bird brains and primate brains are not at all the same. Birds and mammals split on the evolutionary tree 320 million years ago. And since then, their brains have become quite distinct from one another, making scientists question exactly why corvids are so smart. In vertebrates, the pallium is the gray and white matter that covers the brain. Before the evolutionary split, both birds and mammals evolved a large pallium. But after their lineages split, the mammalian pallium evolved into a layered structure known as the cerebral cortex. This is the most complex structure of the mammalian brain. Each layer contains nerve fibers running horizontally and vertically that process and transmit information. Here is where many important functions take place, including learning, memory, sensory perception, and conceptual thinking. Birds don't have a cerebral cortex, but a study published in 2020 found that the fibers and circuitry in the bird pallium are organized very similarly to a mammalian neocortex, with fibers running both horizontally and vertically. The authors believe this explains where bird intelligence comes from. Another reason why birds were initially thought to be incapable of this level of intelligence was due to the small size of their brains. But it's not the absolute size of an animal's brain that matters, but the brain-to-body ratio. Crows tend to have big brains compared to their body size. In mammals, the bigger-brained individuals are humans and dolphins. In birds, it's parrots and crows. However, as scientists' understanding of the brain grew, they discovered it wasn't just size that mattered, or even brain size relative to body size. A big proponent of an animal's intelligence is the density of neurons. This is because having tightly packed neurons leads to better communication between them. And it turns out that certain bird species have very densely packed neurons. In a 2016 study, researchers measured the number of neurons in various bird and primate species. They found that some birds, like corvids, have twice as many neurons as primates with similar-sized brains, with numbers closer to that of larger primates. While these findings tell us how crows are so smart, the question remains as to why. Plenty of bird species thrive with fewer neurons and weaker mental abilities. So why did crows evolve this way? One theory is that it has to do with the way they are raised. Unlike other species, corvids spend more time with their parents. New Caledonian crows are fed by their parents for up to 2 years. During this time, they have ample access to role models who are making and using tools and have the opportunity to use these tools themselves. This extended parenting time allows skills to be transmitted vertically, meaning from parent to offspring. The family groups of many species of crow can be very tight, with young crows even helping to defend their parents' new nest of babies. However, beyond tight family groups, adults of many species of corvids don't lead particularly social lives. New Caledonian crows mate for life, but otherwise don't really interact with other adults. Other species of corvid will often forage and roost in large groups, or work together to mob a predator. But there isn't a social hierarchy or complex social bonds in these settings. This seems to go against one leading theory of intelligence, called the social intelligence hypothesis. Chimpanzees, for example, live in large and complex social groups, where they have to interact with others outside their immediate family and keep tabs on many relationships. It's a constant game of politics. Dogs, wolves, and even orcas have to deal with a great amount of social complexity. And this social intelligence needs a lot of brain power. If adults of many of the smartest corvids don't live in complex social groups, why would a similar intelligence have evolved? Adult corvids may rarely live in wide social groups, but often juveniles do. Before pairing up with a mating partner, during their teenage years, some species of corvids live in larger flocks, aptly called juvenile gangs. And these gangs work exactly like they sound. A bunch of teenagers hang out and bully each other and fight. In these angsty years, corvids, like ravens for example, form the many relationships that they have to keep tabs on. And intriguingly, corvids may need social intelligence to interact with other species. Outside of Yellowstone National Park, certain ravens have been seen interacting with wolves, especially wolf pups. The animals have been seen playing tug-of-war, and the ravens tease and entice the puppies to jump and grab sticks. Sometimes the ravens will even pull the wolves' tails. By all accounts, it looks like the ravens will even pull the wolves' tails. By all accounts, it looks like the animals are playing. Some scientists think that individual ravens may even develop special bonds with individual wolves within a pack. This relationship building may help the ravens more readily scavenge the wolves' kills. This propensity to interact with other species has some groups wondering how we may be able to cooperate with corvids. One idea is to train crows and other corvids to pick up cigarette butts or garbage. A few different companies are developing devices that will autonomously train the birds, giving them a treat once they place the trash into the device. A theme park in France has already been undertaking a similar operation. They trained 6 rooks to pick up trash 4 days a week under the supervision of the park's falconer. While it may seem like we're taking advantage of these birds and their intelligence by having them do something we should already be doing ourselves, those involved seem to have good intentions. It helps the environment, teaches humans to cooperate with another species, and teaches the public about these intelligent creatures. By studying other intelligent species and what made them that way, scientists have gained a better understanding of the brain and its development. And for all we know, we could be overlooking other small-brained species that could harbor a higher intelligence, other animals that can help us unlock the many secrets of the brain. I love talking about animal intelligence on this channel because I love the way the brain works. I love its mysteries and its unbelievable power. And because of this, I love the feeling of learning, of grasping new concepts, of those moments of sudden understanding washing over you. When physics and math and chemistry and biology start to click together, feeling like one beautiful interconnected machine that explains our universe. And I'd like to think that crows feel this too when they get their treat out of the tube. And to engage myself in STEM learning, I use Brilliant. Brilliant is an amazing tool for learning STEM interactively. The quizzes, puzzles, and downright delightful animations make the learning engaging, where it almost feels like a game. And if you get stuck on a particular question, Brilliant doesn't penalize you or impede your progress. Instead, they give you an in-depth explanation to guide you to the right answer, so you can learn from your mistakes. It's easy to learn in this low-pressure environment, and most importantly, it's easy to learn by doing. There are so many courses to dive into, from neural networks to algorithms, to logic and probability, Or my new favorite, scientific thinking. Nature is a puzzle, and in this course you get to learn about principles of physics and engineering by playing with mechanics, energy, and light in a bunch of interactive puzzles. To get started for free, visit brilliant.org/realscience or click on the link in the description, and the first 200 people will get 20% off Brilliant's annual premium subscription. And if you're looking for something else to watch right now, you can watch our previous video about the jellyfish that lives forever, or watch Real Engineering's latest video about the way engineering solved the mystery of the Concorde crash. Hunting from the air is one of the most complex feats of evolution there is. Navigating the world in all three dimensions, while outmaneuvering prey that have evolved similarly impressive escape tactics, is no small feat. When we think of aerial predators, our mind may go to the fierce birds of prey, like the peregrine falcon, who sometimes dive past their prey and then zoom up from beneath it to snatch it mid-air. One study showed they have an overall hunting success rate of 23.1%. Other aerial predators, like hawks, single out individual prey birds from their flock, with a similar success rate of 22.5%. Birds like owls hunt by pinning their prey to the ground, lacking well-developed aerial hunting techniques, but still only have a success rate of around 25%. Other dominant predators on Earth rarely exceed these numbers. Lions succeed less than 30% of the time. African dogs are perhaps the best land-based hunters, with a success rate of up to 67% when working together. But this number still pales in comparison to the greatest hunter on Earth. And to find this predator, you have to set your sights to something much, much smaller, hovering near bodies of water with beautiful wings and huge compound eyes. The dragonfly. Their hunting success rate pushes 100%. Dragonflies belong to one of the oldest insect orders, the Odonata, which have been around for close to 320 million years. Their presence in the fossil record is relatively complete and shows that their morphology has remained mostly unchanged through time. Their size, on the other hand, has changed dramatically. The ancient dragonflies were giants compared to the ones that exist today. What is it about the dragonfly morphology that led it to be arguably the most effective predator alive today? And if this particular body plan is so effective, why did it gradually get so much smaller over the millennia? Why did evolution rob us of a world where almost 1 meter long aerial beasts rule the skies? Odonata means toothed ones in Greek, and these fearsome predators' namesake comes from their prominent chewing mouthparts with sharp teeth found on the underside of their head. Odonates are also characterized for having a freely movable head, very short antennae, large and highly developed compound eyes, 3 simple eyes, and 2 pairs of long wings. The only difference between extinct and existing dragonflies is their size. Some Paleozoic species were known to have wingspans exceeding 70 centimeters, whereas the largest existing species barely exceed a wingspan of 16 centimeters. Males and females can easily be spotted perching and flying around aquatic habitats, as dragonfly eggs must be laid in water. They generally feed on midges and other small flying insects that inhabit the area, and hunt and eat them in mid-flight. And despite being considered relatively primitive insects, dragonflies possess some of the most unique and spectacular flight adaptations of any animal, allowing them both to reach fast aerial speeds and be incredibly agile. One adaptation they possess is something few other insects do: direct flight muscles. Most winged insects have what are known as indirect flight muscles, which attach to the walls of the thorax, making the thorax deform as they expand and contract. The deformation of the thorax transmits its resonance to the wings, making them vibrate and initiate the flapping motion. Whilst indirect flight muscles have their own advantages, dragonflies instead have individual muscles that attach directly to the base of each of their 4 wings. Being able to tug on each wing individually enables them to move and direct each of their 4 wings independently in all 3 axes, meaning they can control their horizontal, vertical, and torsional motion, granting them precision and agility that is unparalleled by most insects with indirect flight muscles. Thanks to this independent control, dragonflies are one of the few insects that can propel themselves in all 6 directions: up, down, left, right, forwards, and even backwards. Another remarkable way that dragonfly flight differs from other insects is their ability to flap their fore and hind wings in different phases, and can vary that phase depending on the maneuvers they wish to perform. One flight technique is known as counterstroking, where they flap their fore and hind wings 180 degrees out of phase with each other. This allows them to hover or engage in very slow forwards flight and can generate large amounts of lift. For fast forward flight, they're able to switch to phased stroking, where the hind wings beat 90 degrees ahead in phase of the forewings. While this generates far less lift, it generates a lot more thrust, with some species being capable of reaching well over 50 kilometers an hour, making them by far the fastest flying insects. Dragonflies can also engage in synchronized stroking, which is when the forewings and hindwings flap together at the same time. This is most useful for increasing their acceleration and to prepare for turning or changing directions quickly. It allows them to generate huge amounts of lift, but can't be sustained for long periods of time, so they generally only use this configuration when chasing prey. In addition, dragonflies are also capable of flying backwards, a flight maneuver which is not possible for almost any other animal except a few other small types of fly and the hummingbird. They do this by tilting their body upwards at 90 degrees to change the direction of the force generated by the wings. And finally, dragonflies can also choose to not flap their wings at all, allowing them to free glide, take advantage of an updraft, or in the case of some female dragonflies, take a ride with a male who can hold onto her, making him beat his wings to propel the 2 of them. Being able to switch between such a wide variety of flight behaviors and aerial acrobatics is what makes dragonflies such efficient predators when hunting flying insects, as well as when evading predators of their own. While not exclusive to the Odonata, dragonfly wings also have a prominent pterostigma. It's a small pigmented spot on the leading edge of the wing that is heavier than the rest of the wing. It acts as a counterweight. From a biomechanics perspective, the weight of the pterostigma displaces the chordwise center of mass ahead of the torsion axis at the level of the pterostigma. If not for this, the outer leading edge of the dragonfly's wing would be prone to self-excitatory flapping and feathering vibrations known as flutter, which would rapidly stall its flight when gliding at high speed. Such aeroelastic flutter and resonance are phenomena that can endanger far larger structures too, such as aircrafts and even buildings, and is responsible for the 1940 collapse of the Tacoma Narrows Bridge. In the case of dragonflies, a small spot that accounts for less than 0.1% of its total body weight allows them to safely reach a 10 to 25% higher flight speed than they would otherwise. Lastly, a dragonfly's wings are not perfectly flat plates. Their veins form 3-dimensional corrugations that make the wing's performance more efficient from a structural perspective. The patterns traced by the veins prevent the wing from warping and deforming as a result of resonance, which enables them to easily alter their angle of attack and generate higher amounts of lift. But it's not just their incredible speed, stability, and maneuverability that makes dragonflies the greatest hunters in the air. It's how they see the world that makes all that agility possible. Dragonflies don't just dominate flight, they have incredible vision. Their characteristic compound eyes are the largest in the insect kingdom. They are made of over 30,000 individual facets or ommatidia, which are like mini telescopes that detect light from the direction in which they point it. As their eyes wrap around their head almost entirely, Their field of vision is nearly 360 degrees, perfect for surveying their surroundings for potential targets without having to reorient themselves on their perch. Each Ommatidia also has 4 to 5 opsins, light-sensitive proteins that absorb different colors of light in the spectrum and allow dragonflies to perceive color from orange to ultraviolet, which is useful for hunting during the day and for detecting and courting females using visual signals. With 30,000 Ommatidia spanning a full 360 degrees, dragonflies do not have the same visual acuity as a human or a bird, but are much more sensitive to movement than we are. A common prey target in the distance will rarely span more than 1 degree across their field of vision before they decide to pursue it, which equates to movement across 2 to 3 Ommatidia at most, meaning their brain is capable of detecting and processing movement incredibly quickly, so they can immediately pursue prey or avoid a threat. Their eyes are also specialized based on region. The upper or dorsal region of their eye is most sensitive to shorter wavelengths of light, that is, ultraviolet and blues. Many dragonflies fly low above the surface of the water when searching for prey, as this allows potential targets to contrast as much as possible with the blue sky. On the other hand, the middle and lower or ventral parts of their eye are sensitive to a wider range of wavelengths. This is likely because color detection is important when identifying and pursuing fellow dragonflies, either as potential mates or rivals, which they are more likely to approach head-on or from above. It can also help when identifying prey that doesn't move, such as insects trapped in spider webs, which dragonflies occasionally loot from unsuspecting spiders if no flying